When we're multiplying exponents, the first thing to check is to make sure that the base numbers, the large numbers on the bottom, are exactly the same. If they're not, you can't simplify the problem. In this one we can see that both of the base numbers are 2, so we're ready to use a shortcut to simplify. Our shortcut when simplifying is just to take the two exponent numbers, so here 3 and 4, and add them together. This means that our answer is going to be 2, keeping the same base number, to the power of 7 as we add the two exponents together. Let's look at another example. In this example, the base numbers are both 4, which means that we can simplify using our trick or shortcut of just adding the exponents. So our answer will be 4, keeping the base number the same, and now add the exponents of 6 and 11, so 4 to the power of 17. Now why does this work? Well, if we go back up and look at this first example again, let's have a look what 2 to the power of 3 means. We know that 2 to the power of 3 is 2 times 2 times 2. So that's that first part. Okay, that's this one here. This 2 to the power of 3 means 2 times 2 times 2. So now if we look at the next part, 2 to the power of 4, that's 2 times 2 times 2 times 2. So that end part of 2 to the power of 4 is 2 times 2 times 2 times 2. These were multiplied together, so we've got our times in the middle here as well. Okay, we know that this expanded form can be written in exponent form. 1, 2, 3, 4, 5, 6, 7. 2 to the power of 7. So we can either write it all out in full, or we can use the shortcut that we learnt right at the start. So when multiplying exponents together, check the bases are the same, and then add the exponents. Alright, now we'll look at division of exponents. So when dividing exponents, we have to do the same thing and check that the base numbers, the big numbers on the bottom, are the same. So in this case we're checking that both of them have the same base number of 4. And now all we have to do is subtract the exponents. So in multiplication we add the exponents, and when dividing we subtract the exponents. So base number of 4 stays the same, and now 3 minus 2 is 1. Let's look at another example. So we check that both the base numbers are the same, and here we can see they both have 12s as their base number. So now we just subtract the exponents. So we'll keep 12 as the base number, and 6 minus 4 on our exponents is 2. So again, we're wondering, why does this trick work? Well, let's go back to that first example and look at what it means in full. So we know that the top line of the fraction is the same as saying 4 times 4 times 4. And the bottom line of the fraction is the same as saying 4 times 4. Now when we've got fractions set up, we can simplify by crossing out something that's the same on the top and the same on the bottom. So this 4 can cross out with this one. And then we can say this 4 can cross out with this one. So how many 4s are we left with? Just 4 used once. So 4 to the power of 1. So we can either write it all out in full, or we can use our shortcut rule. So when multiplying, we add the exponents, and when dividing, we subtract the exponents.